All right, let's look at one last example of relative motion. You're in a boat that is traveling through the water in an area of swift currents. One instrument measures your speed with respect to the water to be 20 feet per second at an angle of 45 degrees as shown in the diagram. However, GPS measures your absolute speed and direction to be 25 at a 45-degree angle as shown on the diagram. So let's go ahead and designate the given information on the diagram. So this is velocity, absolute velocity of your boat, and this is velocity of the boat relative to the water. So again, the key equation in the in relative motion problems is to remember the definition of relative velocity or relative acceleration if that is the case. So relative velocity of the boat with respect to the water is nothing other than the difference between the two velocities. So I write this as VB minus V of water. Since I'm after the unknown VW, I solve this equation for velocity of water. So if I rewrite this, VW equals to VB minus VB slash W minus relative velocity. So I have an unknown vector on the left side and known vectors on the right side. And as far as using sine and cosine, you simply remember that adjacent is cosine, so this is one component of this relative velocity, and the vertical component, let it be this line. So I show these two left and up. Similarly, for VB, I have again two components left and up. So this is cosine, the adjacent side is cosine, the opposite side is sine. So let's rewrite this, and this time instead of taking x and y direction, I want to show you a different way of doing things. So let's say velocity vector for water equals to, I know magnitude of VB to be 25, and I know the direction of it is left and up with an angle of 55 degrees. So this is VB minus relative velocity of B with respect to water, whose magnitude is 20, whose direction again is left and up with 45 degrees. So now I can simply follow the components and decide whether some component is negative if it is to the left or positive if it is up, left and up. So x component of velocity of water is minus 25 cosine 55 minus this vector which is to the left, therefore it is negative 20 times cosine of 45. So the end result is going to give me a positive there. Okay, so continuing with numerical values, this x component is going to be minus 14.34 plus 14.14, which gives me a final value of minus 0.197 in feet per second. I can do the same thing in y direction, and let's take vertical components for the y component of velocity. Observe that both vertical components are up, so I have 25 sine 55. The formula is minus the second component, which is up, so I simply write 20 sine 45. And numerically, I have 20.479 for the first term minus 14.14 for the second term, giving me net value of 6.337. So I have the two components of velocity of water. One component is left, so I draw this left. The other component is positive or up, so this is the resultant velocity of water is this vector here. So this is x component, which is to the left 0.197. The y component is 6.337. Magnitude of the resultant is Pythagorean theorem, so square root of 0.197 squared plus 6.337 squared, and this gives us a velocity of water as 6.34 feet per second. Observe that since the x component is small compared to the y component, it doesn't contribute much to the magnitude, so the final answer is very close to the y component. This tells us that the angle has to be a steep angle. So let's go after the direction of this angle theta relative to horizontal. Theta is inverse tan of opposite over hypotenuse. And note that here I don't want to consider the negative sign because I'm strictly looking at the diagram, the triangle. So this gives me an angle relative to negative x-axis as 88.2 degrees. So this shows you another example of relative motion. Thanks for watching.